Good morning, my dear students. Today, during this revision session, we will do the revision of chemical bond, which is in page number 64. Here we will study what is chemical bond, what are its different types. Since we have studied these things by books, so even you can see the contents of book by yourself. We will do some studies. Same thing we will study, but we will study on the copies with, and we will take a little bit help of books. So first of all, what is chemical bond? Chemical bond, it is a force of attraction between two or more atoms by which they are held together. Two or more atoms, they are held together to form a molecule. See, we know octet rule that all the elements tends to have 8 electrons in the outermost shell except helium and hydrogen. So, if for example we are taking this sodium, it has 281, it will tend to have 8 electrons. Chlorine will have 10, chlorine will have a tendency to get 8 electrons. So all the atoms except hydrogen and helium, they have a tendency to get 8 electrons in the outermost shell. There are two options how they can obtain 8 electrons in the outermost shell. There are two options, and these two options are the two types of chemical bond. So what are the different types of chemical bond? First one is your electrovalent bond, which is also called as your ionic bond. Since these bonds are formed between the ions, between the two ions, two opposite charges, that's why it is also called as your ionic bond. Now the question arises, we are knowing how the ions are formed, either by losing electrons or by gaining electrons. When the sodium, for example, when sodium lose one electron, it will become positively charged, and when chlorine, to complete its octet, gains this electron and now it is negatively charged, this is sodium ion, this is chloride ion, this positive and this negative, means these two opposite charges attracts each other and forms a neutral molecule of sodium chloride. That means this bond is formed by transferring one electron from this one atom to another atom. Orbitically, these are the orbits. This is called orbital diagrams. So from sodium, here is 281 to 281. One is the outermost shell. 7 are in the outermost shell of chlorine. So when one electron is transferred, now it is 28, and here after transferring it becomes 287 plus 1. Octet is complete. Second example, if you see, aluminium, its atomic number is what? 283. There are 3 electrons in the valence shell. Chlorine, all the chlorines have 1 electron. So this 1 electron is transferred to this chlorine, 1 electron is transferred to this chlorine, another one is transferred to this chlorine. So now this aluminium has 28, and all these have 288, means outermost shell is now complete. Outermost shell is complete and it forms ACl3. So what we know, one is loser of the electron, or one is the donor of the electron, another one is acceptor of the electron. So here metal is the donor and non-metal is the acceptor. Here also aluminium is a metal and this is a non-metal. So this bond is formed between metals and non-metals. This bond is formed between metals and non-metals. So these are the examples of electrovalent bonds. So what is electrovalent bond? We should know the definitions. Is the chemical bond which is formed by the transfer of one or more electron from an atom to another atom is called ionic or electrovalent bond, and the compound formed, this is compound formed, is called ionic compound or electrovalent compound. Then second type of bond is your covalent bond. What is then covalent bond? Covalent bond is also called as molecular bond. This is formed by mutual sharing of electrons between each atom. Mutual sharing means both the atoms will share equal number of electrons. See, hydrogen has alone electron in the alone shell. So it needs one more electron to complete its duplet. So two hydrogen atoms share one electron each and they form a molecule of hydrogen. Since one electron is shared, either we show like this orbital diagram, or here is one electron, here is one electron, we put a straight line which represents that one electron is shared. Here oxygen has 2,6 configuration. Both that oxygen atom needs 2 electrons to complete its octet. So both oxygen atom shares 1 electron each, 2 electrons each and complete its duplet. So orbital diagram we will show this one, or even we can show like this. Here are 2 lines. Similarly, nitrogen has 7 atomic number, configuration will be 2, 5. If both the nitrogen atoms needs 3 electrons to complete its octet. So both the nitrogen shares 3 electrons each. So they all are sharing equal number of electrons. Both the atoms are sharing equal number of electrons. So on the basis of number of electrons shared, this covalent bond are of 3 types: single covalent bond, double covalent bond and triple covalent bond. Single covalent bond, when the single covalent bond, the covalent bond which is formed by the sharing of 1 electron each between the atoms. Double covalent bond, when the atoms share 2 electrons, when each atom share 2 electrons, or when the atoms share 3 electrons, each atom share 3 electrons, is called triple covalent bond. You can see here this hydrogen sharing 1 electron each. They form single covalent bond. All the 4 atoms of hydrogen, they are sharing 1 electron with carbon. It is single covalent bond. Like this is ammonia sharing 1 electron. Like this is It is called CCl4 carbon tetrachloride. Like hydrogen, HCl. Hydrogen has 1, chlorine has 7 electrons, so shares 1 electron and forms HCl. These are single covalent bond, while oxygen has 2,6 configuration. They share 2 electrons. Sulfur, it has 2, 8, 6. Like this one, it is called C2 double bond. It is ETHENE, ethene. Double covalent bond. Here is your triple covalent bond like nitrogen, phosphorus, and this is called your ETHYNE, ethine, or even we call it acetylene. This is your local name, common name, and this ethine is your IUPAC name. What is IUPAC name? International Union of Pure and Applied Chemistry. We will see these things in class 10. So far, we can say that it is your international name. It is your international name. And this is your local name. Now, one more thing, my dear students. We have studied about 10 isotopes. What is isotopes? Isotopes are the atoms. Isotopes are the atoms. What atoms? They are different atoms of same elements. Here hydrogen is here. These all are the atoms. This is called protium, this is called deuterium, this is called tritium. So different atoms of same element having same number of proton, means same atomic number, but different mass number. We had seen our regular classes that all the isotopes, they have same number of protons, means same number of atomic number. They all have same atomic number, but they differ in mass number. We know that what is mass number? Sum of proton and neutrons. So isotopes differ in their mass number only due to the difference in the number of neutrons. So, first, what is isotope? Isotopes are the different atoms of same element having same atomic number but different mass number. Here are the examples. There are 3 isotopes of hydrogen, like 3 isotopes of carbon. All the 3 carbons have same sorry Babu. All the 3 carbons, they have atomic number 6, but mass number is 12. One has 13, another one has 14. Likewise, oxygen has also 3 isotopes. Here 8 is the atomic number in all the 3 cases, but mass numbers are 16, 17, 18. Like chlorine has 2 isotopes, 17, 17. Mass number will be 35, and in this case mass number is 37. We should know the properties of isotopes. All the isotopes have similar chemical properties. They will have the similar chemical reactions. They will have the similar electronic configuration. Similar electronic configuration means same electronic configuration they will have. They will have same chemical reactions property, but they differ in physical properties. Physical properties, like they differ in density, they differ in mass, they differ in boiling point, they differ in melting point. So isotope differ in few physical properties, like physical constant or physical property depend on the atomic mass. I told you they are some have more mass number means their atomic mass is more, some has less atomic mass, and the isotopes have different mass number due to different number of neutrons. This is the example we can see. Now what are the applications, what are the uses of isotopes? We must keep it in our mind. This will be once again repeated in class 10 and in class 10. So what are the uses of isotopes? See, cobalt has two isotopes. The cobalt which has the atomic mass or mass number 60, it is used for the therapy, for the treatment of the cancers. This carbon has three isotopes, C12, C13 and C14. The C14 is used for determining the age of historical and geological materials. Very often we come to know there was some vessels or some earthen pots are found whose age is supposed to be 3 years. How we come to know that this was prepared? These pots were prepared 300 years before with the help of this C14 carbon whose atomic mass is 14. This uranium have two isotopes, one is 235, another one is 232. So this isotopes having the mass number 235 is used as the fuels in the nuclear reactor stations or in nuclear reactors. Iodine, they have two isotopes. This isotope 131 is used for the treatment of goiter. You might have seen many ladies and gents that there is some swelling in the throat, that is called goiter, and this goiter is formed due to the lack of iodine. So this iodine therapy is done to cure the goiter disease. Radioactive isotopes are used in industries to detect the leakage. If there is something leakage in the pipes or anywhere, if there is some leakage, this is used in the radioactive industry. So I think this will be our last class. See you, all the best and best wishes for your examination. Bye bye.